So I had this idea that I was going to make a lampshade. It's going to be pretty simple. Take a couple triangles, fill them in with this plastic that I'm using as the filler, and then make a pyramid out of it. Only then I kind of got into a mess trying to figure out the angles and the lengths, and I started looking into the math. And there's a lot of math. Let's walk through this real quickly so that you know the deep math of the carpenter. First of all, we know that it's going to be 10 inches wide. We know that it's going to be 6.5 inches tall. So those two constants allow us to figure out everything else from here. We're going to need to figure out the slant height, which is from the base in the middle all the way up to the top of the pyramid. That's important so I know how long to make these triangles when I'm forming them. But that requires us to figure out first the base, half of the base, and then good old a squared plus b squared equals c squared. We have to go through a little bit of math and we figure out that it is about 8.5 inches once we round it. Then we take a look at the edge height. The edge height is then figured by first having to figure out the distance from the corner of the edge to the middle, which means having to do that same kind of math, only this time take half of the edge and half of the depth in the middle, which is 5 inches squared plus 5 inches squared, and then take the square root of that, and we get that 7 inches or so. Then we plug that in so that we can figure out that 7 inches or so plus the 6.5 inches, a squared, b squared, take that, and we end up with 9 3/5 inches. Okay, so far so good. A little bit of basic geometry. Unfortunately, now we try to figure out the slant angle over here. That's the angle of the slant to the base. This takes trig. Now I'm going to be honest, when I started digging into how to do the trigonometry on this, I realized, hey, I live in the computer age, so I was able to plug this into Excel to figure it out, but I still had to understand the basic so-called tau, which is the sine, cosine, and tangents and all that, so I know which numbers to plug in which way, and then plug that in there to get the tangent, and you get 37.5 degrees and change. I'm actually rounding this down to 37.5 degrees. Then I have to find the edge angle. That's the angle from the base to that slope along the edge, which is going to be different. And I have to remember that 7 inches or so, either that or recalculate it again. And then the 6.5 inches tall. And then we find ourselves with 43.02 blah blah blah, which I'm going to call 43 degrees. And then finally the base angle, which is the angle of that same slope but to the base, not down to the ground, because this is actually a different angle. So again, we're going to plug that in and we're going to figure out the 34 and change and call that 34 degrees. So when we're all done, there's a lot of math involved in this, but if you do your math right, you're going to end up with something that's going to be precisely built, that's not going to be wibbly wobbly, and it's going to be awesome.